Hi everyone! In this short video, I am going to talk about an example that is very typical in this unit. In the learning materials, there are exercise questions for you to practice as well. Okay, before we get into details, it is important to be clear about these two rates. The SPAR rate is defined as the discount rate for cash flow at a specific maturity. The forward rate, on the other hand, refers to the market's expectation of future short-term rates. Using this example, we will construct a theoretical SPAR rate curve from the observable yield curve that is based on the existing yields of Treasury bills and the most recent Treasury coupon securities. And then, based on the derived theoretical SPAR rate curve, we will go through the process of extrapolating the information about expected future interest rates, referring to as forward rates. So here, this is what we have. This table shows information of a list of hypothetical Treasury securities with different maturities and coupon rates, and so different prices and yields to maturity. The goal is to use the relevant information in this table to derive the theoretical SPAR rate curve as shown in the table below. And the formula we are going to use is this one, for bond valuation using SPAR rates that you see in your slides. Let's first consider the 6-month Treasury bill. This is a zero coupon instrument, so its annualized yield of 8% is equal to the 6-month SPAR rate. If you are not sure, let's see how it's derived by calculation. It's always good to conceptualize the analysis using a timeline like this. And as we mentioned already, this formula is the recipe needed to obtain the 6-month SPAR rate. Now, let's plug in numbers. So at time 0, the price paid is 96.15, and then at time 1, 0 coupon, as the coupon rate of this instrument is 0. Together with one final cash flow, the principal or face value, par value, or maturity value of 100. Then, plugging numbers, we see an equation with one unknown variable, R1, which refers to the 6-month SPAR rate. You can easily work out the solution. R1 is equal to 0.04, not the answer though, because in the end, answers have to be annualized. We need to adjust for the frequency, and so the answer is 0.08. Similarly, for the 1-year Treasury bill, the cited yield of 8.3% is equal to the 1-year SPAR rate. The process is exactly the same. As long as you have the timeline set up correctly, the calculation part will be pretty straightforward. So, this is the information relevant for this instrument. And then you put down all the cash flows, then plug in the numbers. An equation with two unknowns, unsolvable? Well, R1 is already derived, which is 0.08 or 0.04 for this equation. But it's actually fine even if you miss that part, as the cash flow is 0, and so this term is irrelevant. You can work out R2 as 0.0415, and the answer is 0.083 on an annual basis, which is exactly the same as the 1-year YTM. For the 1.5-year Treasury bill, it will be slightly different, as now there are periodical cash flows or coupon payments involved. Again, This is the information relevant for this instrument, and you put down all the cash flows, including the final payment. And then plug in numbers. You should be able to solve for R3 as 0.04465, and the answer is twice of that on an annual basis, which is no longer the same as the YTM with the same maturity. Okay, so far we have gone through the first 3 securities, and I would advise that you continue, repeat the process, and see whether you can work out the SPAR rate for the remaining 3 securities. There are 2 takeaways from this exercise. Number 1, the SPAR rate and YTM coincide for zero coupon instruments. And number 2, with the rising YTM curve, the theoretical SPAR rate will increase at a faster rate such that the difference increases with maturity. Next, based on the derived theoretical SPAR rate curve, we can estimate 4 rates. And you can find my notes in the teaching materials on Moodle through this link. Right? Just to remind you that 4 rates refer to the expectation of future short-term rates. Here, we would like to estimate the 1-year 4 rate 1 year from now. It's really important to know first what that means. It is. It refers to the market expectation of the 1-year rate in 1 year's time. To proceed, consider an investor who has a 2-year investment horizon and is faced with the following 2 investment alternatives. Alternative 1, buy a 2-year treasury bill, and alternative number 2, buy a 1-year treasury bill, and when it matures in 1 year, buy another 1-year treasury bill. The assumption is that the investor will be indifferent between the 2 alternatives if they produce the same return for the 2-year investment horizon. And we will use a theoretical SPAR rate curve derived to work out this 4 rate. And as you can see from here, on the left-hand side of the equation, it is the gross return of A1. On the right-hand side of the equation, it is the gross return of A2. Remember that all the yields cited here are annualized, so we need to compound them accordingly. Again, it's one equation, one unknown, and so we can easily work out what x is. Do we need to adjust for the frequency? No, not in this case. It's already on an annual basis. Can you work out this 1-year 4 rate 2 years from now? I'll leave it to you, and you can find the answer in my notes. To conclude, to calculate 4 rates from the SPAR rate curve, the idea is quite simple. You first come up with 2 investment strategies, one consisting of a long-term instrument, like A1 in this case, and the other one consisting of short-term instruments, including the one that you want to estimate, like A2 in this case. Both have the same investment horizon, like 2 years in this case. Then you equalize the gross return of these 2 investment strategies, plug in numbers, and solve for the unknown variable. Typically, as long as you understand the question and set the proper investment strategies, you should be able to get the answer right, as the calculations are pretty straightforward, like this case. Marking does look at the process, and so ensure that you show your steps in the exam, just in case. Okay, that's all I wanted to say in this video. I hope this is helpful, and thank you.